Hello. Now we are going to be, what are we doing? Using series to evaluate a limit. So our limit is going to be, as x approaches 0, of 1 over 3x cubed minus 1 over 2x squared plus x to the 4, plus x minus ln of 1 plus x over x to the 4. So they say specifically use series to evaluate this series. I just was thinking initially what would happen because we would either need to we couldn't plug in 0 because it's divided by 0. We would need to divide by our highest power of x in this, which equals x to the 4. So we'd have to divide everything by x to the 4. And I think once we get here, I don't know if we could do that as easily as one may think because we have an ln in there. So I think this just gets funky. I actually didn't really think about what we would do if we just plugged in x to begin with, but doesn't matter. Our blatant instructions is to utilize series to be able to evaluate this, which I think kind of gives a practical use of series. I feel like it's kind of hard to come across them, at least what I've experienced, it's hard for me to come across them. So this is a good application. It could make our lives easier because this looks funky and series looks funky, but sometimes the funkiness ends up canceling out, which is really, really nice. So what we need to do here is you need to look for the part in this that has a series that we can plug in. In the example problem, it was in the textbook, it was e to the x. So here it is going to be our ln function. I guess in that sense, it's going to be our funkiest function because these aren't that crazy, but this is a little bit more funky than just x cubed or x squared. So I think that's kind of the best way of going about it. If you had any trigonometry, that's probably one that you would end up utilizing. And then once we actually plug in the numbers, we can kind of see what ends up happening, and you'll kind of then be able, once we talk through it, you'll kind of know another way of like looking for these and which one that you would end up needing to use and plug in. So I'm going to plug in our found Taylor series for this. This is similar to our cosine one that we just went through, where we could use a Taylor series or a Maclaurin series to actually find what this series representation is. But the textbook already did that. So we aren't going to walk through that process. We could though, with all of our tools that we have. So all I'm going to be doing is rewriting the beginning of this problem. And then what I'm going to do is I'm going to subtract the series for ln of 1 plus x. So our series here written out, and again, this is going to serve our purposes best if we write this out. It's going to be x minus 1/2 x squared plus 1/3 x cubed minus 1/4 x to the 4 plus 1/5 x to the 5, so on and so forth. So, and then obviously all of this over x to the 4. So another thing that you can be on the lookout for is what we want is for these terms to cancel. Here I'm subtracting a whole bunch of terms that end up looking very similar to the terms that we already have in our problem. So if you're not sure which one to use, look at where we have series for these functions. And if you have that, you can clearly see which ones will end up canceling because our negative is going to distribute to all of these terms. All right, so we actually have negative x and a positive x, so those end up going away. And then we have a positive 1/2 x and a negative 1/2 x squared, so those end up going away as well. And then we have a negative 1/3 x cubed and a positive 1/3 x cubed. So those actually cancel as well. So it's a lot of cancellations. All of the funkiness in the beginning of the problem is now gone. So all we need is we can say our limit. We'll switch these signs now. So I'll say a positive 1/4 x to the 4 minus 1/5 x to the 5. I think that's all. I'll do one more. Plus 1/6 x to the 6th, so on and so forth, all divided by x to the 4. So now all I need to do is divide each thing by x to the 4. I have an x to the 4 here, so those are actually going to cancel. I have an x to the 5 here, and that's going to reduce to 1. I have an x to the 6 here, that's going to reduce to 2. So if I rewrite all these now, I have just 1/4 minus 1/5 x plus 1/6 x squared, so on and so forth. Now all I need to do is just plug in 0 for x, because this is as x approaches 0. So now these terms end up going away. And since my x is just increasing, all of these terms are actually going to end up canceling or going to 0. And the only number that I am left with that I can't plug in a 0 for x for is 1/4. So looked scary, but actually didn't take that long to figure out how to do it. So our limit is actually just going to be 1/4, a 4-step problem. Not too bad, in my opinion. All right. So since I'm doing this video by video, and this one's a shorter one, I'll see you for the next graphing portion.